Hey robot makers, hope you're having a good day so far. So do you want to know how to hack an Ikea Iskarna Head lamp, hope I said that right, and make it react to sound using MicroPython? Then this is the show for you. So let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole load of fun along the way. Okay, let me get over to my keynote and we can make a bit of a start here. There we go. Yes, I'm looking slightly tan today. We went on a walk on Good Friday and I got sunburned. So always wear sunscreen. Yeah, so today is about how we can hack an Ikea lamp, this Iskarna lamp, and we're going to make it so that it can react to sound, and we're going to put in a MicroPython device so that we can program it and make it an Internet of Things. We can do all kinds of things with this project. So we're going to go through what the idea is, the challenges. We're going to go through the bill of materials, what you need to play along to build this. We're going to prep the hardware. We're going to show you how to wire this up. We're going to show you some of the 3D printed parts, and we're going to look at some of the MicroPython code, and of course we're going to have a play with this as well. This is a really fun project to do. And if you're watching live, we'll also have a bit of a Q&A at the end as well. Okay, so let's get straight to it. So the idea inception, we were walking around Ikea last week, one evening last week. We just finished doing up our haul, and we were thinking about getting a few bits and pieces to sort of finish the haul, and I saw this Iskarna lamp and I was like, I just have to buy this. It's a robot head. What more do I need to say there? And it does have inside it an RGB LED. So I've taken off the bottom section of this lamp, and this is kind of the bit that sits. You can just see it on the diagram. If I just put my cursor just here, that's this bit here. So this sort of sits behind the head, and it's got an RGB LED sort of ring light. Might not be able to see it on that camera there. If I go to this one over here and just hold it underneath, you can see much easier there that that's got a ring light there. And inside there are some, not very much, but there's some sort of electronics in there. And there's a single button on the back and a power socket as well. So we're going to have a look at how we can hack this. So that's essentially the idea. I want to be able to hack this lamp so I can make it respond to sound, and we can use MQTT. We can do all kinds of different things to bring this to life. And ultimately, I'd like to make this so that you can talk to it. You can ask it a question, and our AI Alf will be able to respond back. Maybe even plug that into some Chat GPT to make this into like a Uber chatbot. But essentially, it will just flash when you talk to it, different colours. So yes, I'd envisage this responding to a person's voice, glowing when it's listening, so it'll glow blue when it's listening, and when it's responding, it'll glow red. And we can connect that, like I said, to our Alf AI assistant and also to our home assistant, which we're running on a Raspberry Pi. We'll not look at that today, but we'll get the code up and running with this today. So some of the challenges with this, we need a microcontroller for its head. The electronics that are in here are simply, you press this button and it will turn the lamp on, it'll cycle through some colours, and then you can turn it off, and there's 4 different modes for that. But that's it, there's no Wi-Fi connectivity or anything like that. So we need to bring along some kind of MicroPython single board that we can plug in and make the LEDs work. I also didn't know when I started this what kind of RGB LEDs are inside the head. Was it something that we could simply just cut into and then connect to something like a Pimoroni Plasma stick? I've got one of these just to hand here. So this Pimoroni Plasma stick has got all the headers and everything that you need to get up and running with your RGB LEDs, and it's also got a nice Raspberry Pi Pico W on board as well, so we can program this remotely. I've also got to hand one of these Adafruit NeoPixel rings. These come in lots of different flavours. I've also got the larger 16 NeoPixel ring, rather. I think this is a 12, so that's just got slightly more on it. And the one that was inside the original head, that actually has 16 lights on it as well, just for info. I also didn't know what kind of voltage the RGB LED ring would require this one. Since I've taken this apart, I can see these are 12 volt RGB LED NeoPixels, which means that it's something that we'll have to essentially throw this section away and put our own gubbins in, because these are sort of too high power for what we need. The plasma stick 2040W requires sort of 5 volt RGB LED strips, so we're going to use something like that instead, just to make things easier. And we're not sure if there was enough space inside here for all the gubbins that I want to put in there. So a microcontroller, a sound sensor, which is one of these little devices we'll look at in a second, and anything else we might need to shove in there. So we might need to 3D print some parts to make this work. Hint, we will. Okay, so that's the overview. So what you'll need if you want to play along with this, you'll need to have one of these sound sensors. I simply just typed in sound sensor into Amazon, and these things come up. They're about £3, and they're a very simple device. They've got a little pot in the middle. We'll have a look at these in a minute, a bit closer detail. They've got a microphone, and they have 3 pins. They've got like a ground voltage and an out, which just gives you a level you can monitor. So the actual head lamp itself is about £25 from Ikea. The Plasma Stick 2040W is only £12, so that's the brain of the operation. And then the RGB LED NeoPixel ring, and they're £9.90 from Pimoroni when I looked online there. Might be a bit cheaper in the US if you're based there, direct from Adafruit. And also some 3D printing filament, but it's difficult to price what that will be because 3D printing filament is quite variable in price depending on what you've already got. So they're the things you will need. And then preparing the hardware, so very simple to wire this one up. So we're going to be using pin 26 on the Plasma 2040 or the Raspberry Pi Pico W, and that's going to connect to the out from our sound sensor. And that's because GPIO 26 is an ADC, it's an analog to digital converter pin. I don't think every single pin on there can be used for that, but this one certainly can. And we're also going to take the ground from the ground and the 3.3 from the 3.3 out on the Plasma 2040W. We're also going to plug in the NeoPixel ring using the headers at the bottom of the Plasma 2040 Plasma Stick 2040W, so that's 5 volts ground and the actual data line for the pixels themselves. So that's how we're going to wire this one up. And on the sound sensor itself, there's this little blue thing. So this little blue pot on there, this little potentiometer, you can simply put a screwdriver into that, like so, and twiddle with it until you get the sound level just right. And we'll have an experiment with that in a minute. There's 2 LEDs on here, one which is just showing that there's power, and the other one is the current sound level, that potentiometer is sort of the threshold, so you can sort of dial it up or dial it down so that it flashes when you speak, which is essentially what we're going for. So that sort of trigger, it's analog. You can also do it in code later on. If you want to, we can just play around with the MicroPython, essentially just reading in 2 bytes there. The sound sensor outputs are analog, so they're a value between 0 and 65,535. Now we've also got help from Pimoroni on the chat at the moment. I can see there she's saying about the Plasma can do data for 12 volt LED strips, but you'll need to power the LED separately. So I like the simplicity of everything sort of just being connected up there. But we could, in theory, have used these RGB LED pixels in there. We'd have just had to sort of cut into this wire and split it different ways and use the original power in there. So we could have done that, but then we'd have to figure out how do we drop that 12 volts down for the Plasma 2040 itself. So we'd need to be able to provide 5 volts in there. But I thought we could use that the micro B USB connector on the end of the Plasma Stick to power it and to program it as well. So nice and simple there. Okay, so the 3D printed parts. So there's an interesting little anecdote we can go through here. So when I disassembled this head, when I disassembled this head, I noticed a couple of things. So the RGBs are 12 volts. They are these APA 102 4Y variety rather than the 3Y variety that we have on the Plasma Stick. I think the full-blown Plasma 2040, which doesn't have Wi-Fi, that can do both different types because it has 4 terminals on there. But I'm using the one I wanted Wi-Fi, so I'm using the Plasma Stick. So what I thought was I'll just design this in Fusion 360, but one of the challenges is it has a curve on it. So this base has this sort of curvature. Let me try and get that on there. You can see the curvature which follows the base of the head round. So we need to sort of model that in Fusion 360. Now the other parts of it, I can get a caliper, I can measure that, I can measure all the different distances and the corner radiuses, the height of these different things. They're easy to measure, but that curve is a bit of a challenge. There's also a sort of circle cylinder thing that sticks out, which pushes into the head. Again, that's quite easy to measure because we can get calipers around that, measure what the distance is there. We can also measure the height from the base there as well, so it's reasonably easy to measure that. So I'm going to basically redesign that in Fusion 360 and then produce the 3D printable files from that. And that means we can make it so it's custom for our plasma stick. So we can get our plasma stick 2040W, and we can measure the width of this, and we can make it so that this will fit into the base nice and snugly. This doesn't have any mounting points on it itself, so just to keep the size small, but that doesn't matter because we can make it so it's a friction fit. So that's what we're going to go for. And the top of the stand, so this comes in sort of two sections. There's a base section and then there's sort of this top section. I'm going to follow that exact kind of method to reconstruct my own, and I'm going to make this so that this can also house the NeoPixel rings as well on there too. So that's what we're going for. So the 3D printed stand, so like I said, it's got this curve to it, which is tricky to model. So one of the techniques I thought would be straightforward enough, and sure enough, it worked really, really well. I simply got my camera and I took a picture so I was completely planar to the side of it, so it wasn't sort of an angle, and that meant that I got a really nice snapshot of what that angle looks like. So I made sure I was quite a distance away from it and took it so that you don't get sort of a perspective warping or anything like that. So that photograph you can see on screen there, that's the actual one I used in Fusion 360. And then you go into Fusion 360 and you can import that as a canvas, and you can resize it to the correct size, and then you can trace the curvature on it. So that's exactly what I did. I went into Fusion 360, I used the fit to spline tool, and I basically just plotted out a number of points. I think there's only 3 points, three parts of the curve, maybe 4 points on there, and that meant that I could then tweak them with little Bezier curves to get that just right. You can see on there a couple of the measurements, and then I basically just lock them in place by using these additional measurements. So I usually round up to the nearest round number, and that meant that we could then extrude all the different parts and then send this to a 3D printer. So I've modelled all that up. I'll include that in the files for this write-up, so you can download them if you want to print that out too. So that means we've got a nice 3D printable section for the head. We'll have a look at that in a second. I'll show you how that actually works. So next up, we'll have a look at this sound sensor. Just dropped my screwdriver. So these little sound level sensors are really, really great. Very, very simple. Because of an integrated circuit, that little chip on there does all the sort of heavy lifting for you. So you can simply just put sound there. It is a microphone, but we're not recording the actual waveforms of the microphone per se. We're just recording the level of sound. So these are quite tuned for voice. So they're perfect for what we want to use. So this simply has 3 pins on the back. We have voltage, we have ground, and then we have out. And out just it outputs 2 bytes, and we can measure that with our analog to digital converter class in MicroPython, and then we can basically just get a value between 0 and 65,535, I think it is. So we connect that to pin 26 because that has the ADC capability, the analog to digital converter, on the Raspberry Pi Pico W, the plasma stick. So that's what we're going to go for, and then we have that little blue potentiometer there, that little pot, and we can just twiddle that with a screwdriver, and we can get that so it's just the right level that we want. And there are 2 LEDs. There is one on this side here, which the right hand side one, as you're looking at it like this with the microphone at the bottom, that one just shows that there's power going to it, and then on the one on the left hand side here, that one shows that the threshold that you've tweaked this thing for is being sort of breached, and you'll see it sort of flash on and off as you speak and make sounds near it. So very, very simple, very cheap. So these are great to add to your projects. They play very nicely with 3.3 volts or with all microcontrollers. So if you want to do me a favor, you can hit the like button, you can drop me a comment, let me know if this is something that you're interested in. Have you seen these lamps before, IKEA? Is there any other IKEA stuff that you want to play with? I did buy a bunch of trad-free, they're called, home automation lights and stuff. So I'll be plugging them into my studio shortly. And if you want to make sure you get notified whenever I do a new video, then just click that little bell button as well, and you'll get notified. So yeah, subscribe. And I do go live every single Sunday at 7 o'clock, either Greenwich Mean Time or British Summer Time, whichever time we're in. So you can check me out live as well. Okay, so we now have merch. This is new this week. Hopefully at the bottom of the YouTube player, you'll see that there's now a little shelf that's appeared. And I've simply just created, I'm going to get rid of my old streamer hat and have my own robot maker hat. This is really me gearing up for the event in May, the NEC. So I want to have my own hat on there. And I've also designed a little mug using the Kev's logo, kevsrobots.com logo. And you get hoodies, you get t-shirts, you get a Bubo t-shirt. So I'm going to get one of those. I've just ordered one for myself to try out. And there's also a Bubo mug as well, all available in different colours. These are all the Kev's Robots colours as well. So yeah, check out kevsrobots.com/merch. You'll be redirected to a Teespring site and you can knock your socks off there. Okay, so the MicroPython code, let's have a quick look at this. Really simple code, so this means that we can get up and running and playing with stuff quicker. So yeah, we're going to connect the sensor to pin 26, and we're going to create an ADC variable, which means we can interact with that pin, with that sound sensor in our code. And if the sound level is less than a certain threshold, we can get the onboard LED to switch on. So on this particular one, I've got some... I have a Raspberry Pi Pico, not the W, just the Pico on my my desk here. I'm going to have a play with the Pico Explorer, just because that makes it easier to do these kinds of experiments. So I'm going to have a play with that in a second. But if we look through the code there, so from machine we're importing pin. That means we can play with pins on our Pico. And we're also importing ADC, which is that analog to digital converter. We're then going to use the ADC. We're going to say noise equals ADC pin 26, and that tells MicroPython that on pin 26 we want to use the ADC, and we want to call that noise. And then we're going to use the onboard LED. So on a Pico, like this one here, for example, that doesn't have the Wi-Fi, that's pin 25 for the onboard LED. If you're using a Pico W, then you can put in some speech marks LED in capitals, and that will do the same thing. And pin out just means it's an output because we're switching an LED on and off. It's not an input. We're then setting the sound level to be 0 to begin with, and then we've got a little while true loop, which means it'll just run forever. And we say sound level equals noise.read underscore U16. So what does U16 mean? So in MicroPython, an unsigned integer can be a byte, can be 2 bytes. So 2 bytes or 16 bits means that we can use the full value of those 2 bytes. So that means we can store a number up to 65,535 using an unsigned 16-bit integer. So that's what value is going to be read in from the sound sensor. So sound level will contain a value between 0 and 65,000. We can then say if the sound level is less than, say, 60,000, then switch the LED to on, otherwise make the LED off. And if we then speak across our little sound sensor, we should see the LED flicker on and off with our voice levels. So we'll try that in a second. We'll try that now. So let's go over to... Now I've also got another thing that we could possibly use, which is these... just go full screen for a second. Simon Monks makes these sensor boards, and they have a little microphone on there as well. So these are 3.3 volts friendly, and you can simply use like crocodile clips like this to clip these to your Pico if you want to. So I was playing with this before the other soundboards arrived. I blew one up, of course I did. I put the ground and the voltage the wrong way around, and it stopped working. There was no magic smoke, but it basically did stop working. So these haven't got really very much protection in them. So I reverted to using this Monk Makes board and plugging this into the various different pinouts. So that's why that's mentioned there. Right, so let's go over to Thonny. Let me just bring up Thonny here. And what we're going to do, we're going to play around with, let me find the right one. So I've called this chat RGB. So this is the code that we looked at just a second ago. And what I'm going to do is just plug in the board that we're going to use. So let me just get my wire, plug that in. Okay, and then I'm going to click the start button there. Okay, and then I'm going to click run. And what I will do, I'll go to the captain's table view, and if I get to the, in fact you can see that there. So when I speak, you can see near my thumb there's a tiny little LED that's lighting up. You can also see if I just turn off the head for a second so that stops doing its thing. Turn off. There we go. the head's just plugged into a battery, so I can unplug that. There we go. So as I speak, you can see the LED flickers on. And if we look on the little board, which is under here, I zoom in a little bit, we might be able to see that a bit easier. So let me just zoom in there and move this into view. So I've got the board, which has got 2 LEDs on it. Get that into view there. And then there's the Pico. So if I move my arrow here so you can see what's going on. Let me see, how can I do this so you can see it? So let's just put the overhead light on for a second, just so you can see what's going on. So the power light is this light here. And then the light that's here is the onboard integrated circuit LED that's sort of showing you the sound levels. And then on the Pico, we can see there's an onboard LED, and that's also flickering at the same rate as the one on the integrated circuit. So you can see that it's taking that value and it's reading it in. Now, one of the things, if you try and print this out to the terminal, so let's put a print, let's do it just at the end of our loop. So print, let's say noise level, and then let's put in there sound level. Should I call it sound level? There we go, sound level. Okay, let's run that. Let's see what happens now. So we can see in our little monitor at the side here, when I speak, it'll react. Now the print command is a bit slow in Thonny, so it doesn't always do it in real time. So you can see the pins are reacting in real time, but the actual screen is sort of playing catch up a little bit. So if I sort of tap this, you can see that it's not too bad. But we've got the threshold there is right up to almost the 65,000 mark, so it's 6,460, 70, something like that. So if we want to dial that down, we would just have to change that value in our code, or we can play around with the our screwdriver and that potentiometer to adjust that. So let's just change the value of the potentiometer. I'll just find where to put my screwdriver, and let's just adjust that and see what happens. If I twiddle this, so if I'm moving that, let's see, I'm basically just moving this to the left and to the right. And you can see there that the threshold means that it thinks that they sound all the time now. Whereas if I keep turning clockwise, there becomes a point just about here. So now it's flashing on when I speak, and it's going off when I stop speaking. So that's about the threshold that we want it to be dialed in at. If we turn it too far, then in fact that looks a bit better. So when I'm speaking now, it goes off completely when there's no sound. So it's been sort of squelched correctly. So this little board I'm using, by the way, is a Pimoroni Pico Explorer. These are really great for doing little experiments. So I've got the sound thing connected in to all the different pinouts there. So you can see we've got, if we can get that to focus, we have 3 volts, we've got ground, we've got ADC 0. So it's just the first 3 pins. And we've got the Pico plugged in just there as well. So nice and simple. So that's the first piece of code. We can test that our device is responding to sound, and we can capture that as a value between 0 and 65,000. Now, some code I've seen online, they actually use a mapping function to bring that down to sort of a value between, say, 0 and 100. So you've got like a percentage. So you could do that if you wanted to, using a mapping function. We've looked at mapping functions before on this show. We've used them quite a lot with some of our other projects. Okay, let's go back to our keynote and let's get over to the next piece. So the next piece of MicroPython code is going to be looking at how we can turn an RGB LED strip on and off. So if you bought one of these Plasma Stick 2040Ws, you'll probably have seen some of these types of code before. These are very simple. You can basically just use the built-in Pimoroni libraries to interact with this. It makes the whole thing a lot easier. So we can say if the sound level goes above a certain value, we can make the red RGB LED the prominent color, Otherwise we can set it to 0. And I've also got this class that I've called glow, and what that will do is it will set the value if you provide it, and then over time it'll just drop that down to 0. So over, say, maybe a second, it'll go from like the high value 255 down to 0. And that makes it so that it's less on and off, and it's more like a gradual kind of response glow. It looks a bit more like the way, say, Kit used to speak to Michael Knight on Knight Rider, that kind of vibe. So that's what glow does, and light on will simply just set the LEDs to whatever the current RGB values are. So what I want for here is I want the head to glow blue, so it'll go from 0 to 255 in blue while there is no sound, and as soon as there is sound I want that to stop, and I want the red value to be 100%, to be 255, and then that to drop down. And once that drops down to 0, then the glow, the blue thing, will start to work again. So that's what this code here does. It will say grab the current noise level. If the sound level is above 35,000, that's just what it was on that particular sound sensor. Then if the LED value, set the onboard LED value to 1, so make that go on. Set the red value to 255 and the blue value to 0. Otherwise, set the red value to 0 and set the blue value to be whatever glow currently has. So glow's got a little internal value that it can maintain, and it can increase or decrease as it sort of glows. So there's a piece of code we can look at if you want to do that. Otherwise, it'll set the LED value to 0, so that's the onboard LED, and then the RGB will be fade, so it'll fade whatever the colours are, similar to the glow thing. So light on simply just puts all the LEDs on to whatever their current values are, and then we sleep just for is that a tenth, a hundredth of a second, just enough time for the LEDs to get the value and to be set. Okay, so I think we're going to have a play with that now, and let's see what this looks like. So over here on the, let me go over to Thonny. We have another piece of code which is called LED strip test. So what I will do on this one, I will plug in the actual head itself so we can have a play with it. Let me just move my wires around. And let me get the head into view. So let's go to the overhead for a second. Let me zoom back. And let me turn off the overhead light just so we can see it a bit easier. Right, what I'm going to do is I'm going to run that code now. So I'm going to run the LED strip test. So you can see there it's glowing blue. And when I speak near it and I speak loudly, it will respond to my voice, and you'll see that it flashes stronger when I speak. And if I leave a little gap between my words, you can see it responding there, and the glow dropping off, like so. We can look at that from another angle as well. Let's go for these angles here. So you can see when I speak, it glows nicely. And when I stop speaking, it'll go blue. So let's just let it glow blue for a second. And then when I speak, it'll glow red. It's like something from, remember the original 60s Batman? They had a bat phone and that sort of glowed red when somebody was ringing it. I always liked that. So this works surprisingly well. I'm really, really pleased with this. I did blow one of these up the first time round, just because when I was soldering the wires onto the Plasma 2040, I got the colours wrong. So the 5 volts went to ground, and the ground went to 5 volts. There's no sort of magic smoke or anything, but it did mean that particular board stopped working. But these are cheap enough that I was able to buy a couple of extra ones spare too. So this means that we can now do things like if we get, let me go into, so on an Apple, you can use something called text editor. Let me go over to my screen, let me find text editor. Let's go for that. Where's text editor? Let me just quit that. Oh, it's trying to create a document, that's what it's trying to do. Let's do that again, new document. Here we go. Let me make sure we've got the volume switch right up, and you can go to edit, speech, and start speaking. So if I do this like here.
Hello robot makers.
So it says hello robot makers. Let's make it say something else. What we could do, we could go to, let's see, ChatGPT. Let's go to ChatGPT and let's get it to tell me a short story. There we go. So this is just going to quickly grab me some text there. I just wanted to get something. Let me just grab that. Okay, let's go back over to our text. Let's paste this in. And let's now run this. And I'll be quiet and I'll just let it speak.
Once upon a time, in a small village, there lived a young boy named Jack. Jack was always curious about the world around him, and he loved exploring the nearby forest. One day, while Jack was exploring the forest, he stumbled upon a hidden cave. Jack was hesitant at first, but his curiosity got the best of him, and he entered the cave. Inside, Jack discovered a treasure chest filled with gold coins and precious gems. Jack was ecstatic and decided to take some of the treasure back to his village.
Little glow blue again. So what I was going to go for with this, let's turn the volume down there. So rather than trying to figure out some complicated way of getting our AI speech output to mimic that kind of really natural looking glow when you speak. So when you speak, it sort of glows. If I put that on screen there, so you can see. So when I speak, it reacts to my voice by flashing on the volume of my voice when I speak and the high notes. Rather than trying to figure out how to do that in our AI, I thought we could basically just put a speaker next to this or inside this so that it would have the same effects. And although it's a little bit convoluted, it would work really well. And I thought what we could probably do with MQTT is set the color. So we could have, if you ask a question, we could have the head respond green. So it flashes green rather than red like this. And then when it's responding, we could get that color to change by MQTT, because in our MicroPython code, in our Python code for our AI, there is a really nice plugin feature that I created. Before speech and after speech, you can get it to do things. So we could say before speech, set it to green, after speech, set it back to red, or all the way around, set it to red and then back to green. And that would have the effect that it looks like it's listening with blue. When you ask it a question, it looks like it's flashing and listening in green. And then when it responds back, it flashes red. So that was something I was thinking we could do to improve this. And because we have the capability of connecting to the Wi-Fi network with the Plasma stick, because it has Pico W on board, it's got the little Wi-Fi connector there. That means that we can do all that kind of cool stuff. So I've not had time to do that today, but that's something I'll certainly be looking at for future. So love how that's flashing away there as I speak. It's really quite cool. So let's get back to our keynote. See what there is next to look at. So yes, if you've not joined our Discord server, you might want to go and check out kezrobots.com/discord to get a sign up link there. We've got a couple of hundred people on there now. I don't think we've quite reached 200, but I don't think we're far off actually. So yes, a growing community of people who all love robotics and can help you out with the kind of problems that you might have whilst you're building your robots. And if you've not checked out the kezrobots.com website, you're missing out. There's so many resources, and I'm actually going to release a new version of it this weekend. I've just been reorganizing some of the layout to make it a lot easier to sort of consume the content, because it is quite content heavy. There's a lot of stuff on there, so I've kind of made the sections a bit easier to read, and I'll be putting the notes for this particular build on there too, so you'll be able to find that. So if you're going to find out how things work, there's all kinds of articles on there about how different components work. I'll certainly be adding one about how the sound sensor works, but I've just lost there. So I'll grab one of these and do an article about how sound sensors work, and we can add that to the repository. There's also a massive glossary on there. And if you've not followed me on social media, you might want to consider doing that. So if you go to Kevin McAleer 6 on TikTok, I drop some videos on there probably about once a week. On Instagram, I'm at Kevin McAleer. I do put videos on there and pictures on there all the time, as well as builds in progress. And if you're not on Twitter, you can find me on Mastodon at kevsmac at mastodon.social. And I'm also on Twitter at kevsmac on there too, which is probably where I spend most of my time still. Okay, and if you want to help the show, there's a number of different ways you can do that. You can also buy merch now as well. That also helps support the show. And there's some nice mugs. I'll be able to show you these once they arrive. I'll be able to drink out of my coffee cup and wear my official hat when they arrive, and the t-shirts too. But if you want to help the show now, you can do a super thanks. Make sure I've got the widgets enabled for that. I think I have. Yep, Stream Elements is enabled there. So if you want to do a super chat, you can do that live now. A super thanks. I always get this one the wrong way around. Super thanks is if you're watching this on replay. And then there's also kedsrobots.com/coffee if you want to buy me a physical coffee or a Diet Coke or a Diet Pepsi. You can do that too. And if you want to join the YouTube membership program, there is a little join button underneath this video player, wherever it's down there somewhere, that you can click. So I think after you've subscribed, you can also do a join button, and it's the price of a coffee per month as well. So there's a number of people I want to give a shout out to who've supported the show. So we have, is it Mikkel? Is it Michael? Is it Michelle? I'm not quite sure. The person who donated a coffee this week, and also Matt. Thank you so much for those coffees. Really, really appreciate that. So we've got Marin, we have Victor, we have Marlene, John, we have Tom and Shemi and Steve, who are members as well. And on the YouTube membership, we've got Dale, we've got Carol, we've got Jose, Skipper Banks, Jeff Ford, W. Peabody, Bill. We've got Hans from Cheerlights, we have Michael, we have Fraser, John Paul, and we have Tom, of course, as well. So thank you so much for supporting the show. I really, really appreciate that. Okay, and I think that is everything I wanted to cover for today. I've got this nice outro that I created as well. I put that onto all the YouTube shorts and other bits and pieces as well that I do online, so I quite like that. Cool, so this is the point in the video where I'll say thank you so much for watching, and I shall see you next time.